Welcome back to our YouTube series on polymers we encounter at almost every corner. We hope you've enjoyed our past videos on gloves, masks, eye protection, and absorbing materials for PPE.
We're going to take a bit of a turn this month with today's video serving as a setup for the remainder of our video series. So the remainder of our series is going to focus on biomaterials. So we'll talk today about what biomaterials are, why we need them, why we use them, and some general considerations for the field of biomaterials. So let's go ahead and dive in. Now, at the heart of biomaterials is the concept of biocompatibility. At a base level, biocompatibility means that the material will not trigger adverse reactions with a biological system, such as a human, and will not allow for leaching or extraction of low molecular weight components from the material into the biological system.
Right, and so this concept's important as we would not want a polymer material for a biomedical or biological application to introduce potential toxic substances. There are several other common properties that we're going to aim for with biomaterials, biodegradable materials, responsive materials, and also non-fouling materials.
Those are great points. So let's tackle the biodegradable materials first. These are materials designed to perform their desired function, yet be able to be resorbed into the body.
Right, and so we can imagine things like dissolvable sutures being really good examples of biodegradable materials.
Yeah, and we'll talk about those later in this series. So wait, let's consider the second property, these smart or responsive materials.
Right, these are materials that respond to stimuli and elicit a new behavior. Right, and so things like dental resins might be in this category. When we first apply them, they flow and they conform to the surface that we're going to shape it into. And ultimately, upon application of stimulus, such as light, we actually turn the dental resin into its final.
Okay, yeah, and in a few weeks we're going to look at prosthetics, and there's a few considerations to make there. One example or one aspect of the behavior needed for prosthetics is really for the materials to be non-fouling. And what we mean by non-fouling is the ability for that surface to resist absorption of proteins or the adhesion of cells. This is important for prosthetics and implants so that contamination by pathogens can be reduced and that undesirable adhesion of cells does not lead to rejection or malfunction of the prosthesis. Now, what about biomaterials that are inherently hostile to biological systems, right? So, for example, we might not mind having a material or a surface that could kill bacteria, right?
Right, that's correct. We'll look into two different approaches in our upcoming biocidal paints episode. This includes the ability to keep biological organisms like fungi, bacteria, and algae from growing in bulk paint containers as ways of incorporating these polymers into paint to prevent these biological organisms growing on the paint once it's applied to a surface and cured. The final category is incorporating polymers into healthcare and their production. We'll have a few episodes on this coming up soon.
That's correct. And polymers are used throughout the healthcare industry. Adhesives are one crucial but often overlooked area. These adhesives need to be strong yet flexible, and all while maintaining biocompatibility. Polymers can also offer opportunities to create medicines with new properties and are an essential part of the pipeline for producing drugs, particularly biologically derived medicines. And we're going to look at a little bit later in this series at the role of polymers in the coronavirus vaccines and in their production.
Yeah, it looks like we're going to have a lot left to discuss in our series on polymers we encounter at almost every corner.
I agree. There's a lot left to discuss, and polymers are so versatile. There's really so many interesting and roles to uncover.
Right, and that's sort of a wrap for today. So we hope you sort of enjoyed our little preview of the polymers we're going to encounter in biomaterials. So stay tuned to this series for follow-up on dental resins, adhesives, prosthetics, and lots of other things. But for now, thanks a lot, and we'll see you soon.
Bye.